Good day, I'm MARIZ from BSCE 3A. So our topic is about traffic engineering, the traffic characteristics. So it includes two subtopics, which are road user characteristics and vehicular characteristics. So under the vehicular characteristics, there are also two, which are the static and dynamic characteristics. So in this section, I'm going to focus on the dynamic characteristics. So let's start. So vehicular characteristics. As mentioned earlier, the vehicular characteristics include static and dynamic characteristics. Criteria for the geometric design of highways are partly based on the static, kinematic, and dynamic characteristics of the vehicles. Static characteristics include the weight and size of the vehicle, while the kinematic characteristics involve the motion of the vehicle without considering the forces that cause the motion of the vehicle. In short, that here in static, it talks only about the attribute or the attribute of the vehicle itself. While for the dynamic characteristics, it involves the forces that acting on the vehicle in motion. Under the dynamic characteristic, I'm going to discuss the four forces or resistance that acting on the vehicle in motion, which are the air, grade, rolling, and curve resistance. In addition, power requirements will also be discussed. Now let's first define what is dynamic characteristics. Dynamic characteristics involve the forces that cause the motion of the vehicle. So unlike the static characteristics that mainly focuses on the attribute of the vehicle itself, so dynamic characteristics focus on the forces that acting on the vehicle in motion. The significance of studying this particular topic, the dynamic characteristics, is it will serve as an aid for the highway and or traffic engineer in designing highways and traffic control system that allow the safe and smooth operation of the moving vehicle. As we all know, that the main objective of engineers is to create a structure that is safe to use. So next, as I mentioned earlier, so there are four resistance that acting on the vehicle in motion: the air, grade, rolling, and curve resistance. The extent to which these forces affect the operation of the vehicle are discussed in this section. The first dynamic characteristic is the air resistance. Air resistance is the force required to overcome and is related to the cross-sectional area of the vehicle in a direction perpendicular to the direction of motion and to the square of the speed of a vehicle. So a vehicle in motion has to overcome the resistance of the air in front of it, as well as the force due to frictional action of the air around it. As you can see, the air that is mentioned here is not only the air that acting in front of the vehicle, but also the air that acting around the vehicle, which is the frictional action of the air around it. Cliffey has shown that this force can be estimated by the formula R sub A equals 0.5 times the quantity 2.15 P C sub D A U square over G. So the A sub A is the air resistance force, which has the unit pounds. P is the density of air given by the value 0.0766 pounds per cubic foot at the sea level. The density of air is less at the higher elevation. C sub D is the aerodynamic drag coefficient, where for the passenger cars, the current average value is 0.4, and for the trucks, so it ranges from 0.5 to 0.8, but typically the value is 0.5. A for the frontal cross-sectional area, which is in square foot, U for vehicle speed in mile per hour, and G for acceleration due to gravity. Now let's move on to the second dynamic characteristic, which is the grade resistance. So the grade resistance is the force acting in the direction opposite to the motion when a vehicle moves up a grade and the component of a weight of a vehicle acts downward along the plane of the highway. For example, this vehicle, so it's moving upward, and the grade resistance is it pulls downward, since the grade resistance is one of the factors is the gravity. A vehicle traveling up a grade will therefore tend to lose speed unless an accelerating force is applied. So the speed achieved at any point along the grade for a given rate will depend on the grade. Grade resistance is the opposing force due to the gravity of the frictionless slope. So the formula for the grade resistance is as simple as the weight times the grade. Commonly, the grade is given in percentage. So to solve for it, so we need to convert it into decimal value. The third dynamic characteristics is the rolling resistance. Rolling resistance is the forces due mainly to friction effects on the moving parts of the vehicle, including the friction slip between the pavement surface and the tires. The rolling resistance depends on the speed of the vehicle and the type of pavement. Rolling forces are relatively lower on a smooth pavement than on rough pavement. Therefore, the surface condition of the pavement has a significant effect on the rolling resistance. There are two formula for the rolling resistance, which depends on the type of vehicle. So the first one is, this is the rolling resistance force for the passenger cars on smooth pavement. So the formula is sub r is equal to the quantity C sub rs plus 2.15 C sub rv u squared multiplied by w, where the r sub r is the rolling resistance force given by the unit pounds. The C sub rs, it's constant. So typically for the passenger cars, it is given by the value 0.012. For the C sub rv, it's also constant. And for the passenger cars, it's 0.65 times 10 raised to negative 6 square second per square foot. The U same with the air resistance, it is the vehicle speed, and W is the gross vehicle weight, which is also in pounds. While the rolling resistance formula for the trucks is given by R sub R equals the quantity C sub A plus 1.47 C sub B U times W, where R sub R is the rolling resistance force. The C sub A is also constant, so for trucks, it is typically 0.02445, and for C sub B, it's also constant, 0.00044 for trucks, and the U is also the vehicle speed, and W is the gross vehicle weight. Now let's have this example situation under the rolling resistance. So at the speed of 50 miles per hour on a badly broken and patched asphalt surface, the rolling resistance is 51 pounds per ton of weight, whereas at the same speed on the loose sand surface, the rolling resistance is 76 pounds per ton of weight. This example shows that the surface condition of the pavement has significant effect on the rolling resistance. So as we can see, they have similar speed, which is 50 miles per hour, but different surface condition. Like yung first one is it has badly broken and patched asphalt surface, and the other one is has loose sand surface, and it shows that vehicle that has broken and patched asphalt surface has lower rolling resistance, which is 51 pounds per ton of weight, unlike on the loose sand surface that a vehicle traveled, which has the rolling resistance of 76 pounds per ton of weight, which is infinitely higher than the previous one. Now let's move on to the last dynamic characteristics, which is the curve resistance. Curve resistance is the external forces act on the front of wheels of the vehicle when it is maneuvered to take a curve. So these forces have components that have a decelerating effect on the forward motion of the vehicle. This resistance depends on the radius of the curve, the gross weight of the vehicle, and the velocity at which the vehicle is moving. The curve resistance can be determined using the formula R sub C equals 0.5 times the quantity 2.15 U squared W all over GR, where R sub C is the curve resistance, U is the vehicle speed, W the gross vehicle weight, G the acceleration due to gravity, and R is the radius of curvature. Now let's move on to the power requirements. Power is the rate at which work is done. It is usually expressed in horsepower, a US unit of measurement, so where 1 horsepower is equal to 550 pound-feet per second. The performance capability of a vehicle is measured in terms of the horsepower the engine can produce to overcome air, grade, curve, and friction resistance forces and put the vehicle in motion. This image shows the forces acting on the moving vehicle. We have here air resistance, the rolling resistance, the friction between the tire and the roadway, the grade resistance, the weight of the vehicle, and here is the tractive force delivered from engine. This is the one that we measured in terms of horsepower. Therefore, the engine must produce necessary tractive force to overcome all of the resistance forces that acting on it while the vehicle is in motion. The power delivered by the engine is given by the formula P equals 1.47 RU all over 550, where P is the horsepower delivered, R is the sum of the resistance of motion, the U is the speed of the vehicle. Now let's have an example. So what we need to find is the vehicle horsepower required to overcome resistance forces. The problem is determine the horsepower produced by a passenger car traveling at a speed of 65 miles per hour on a straight road of 5% grade with a smooth pavement. Assume the weight of the car is 4,000 pounds and the cross-sectional area of the car is 40 square feet. The first step that we need to do is to identify which among those 4 resisting forces we can use to solve this problem. As stated here, the passenger car traveling on a straight road, which means that there's no curve resistance. Therefore, to find the resistance, we only need to compute for the air resistance, grade resistance, and the rolling resistance. Here is the solution. So for first, determine the air resistance. So the formula is RA equals 0.5 times the quantity 2.15 P C sub D A U squared all over G. As mentioned earlier, P is constant, so it is given, which is 0.0766 pounds over cubic foot. And then CD is also constant. So the CD for the passenger cars is 0.4. A is 40 square feet. So since it's mentioned here 40 square feet, the cross-sectional area, the speed or the vehicular speed is 65 miles per hour, and G is the gravity, which is 32.2 feet per square second. Next step is substitute all of the given to the formula. So it gives us 0.5 times 2.15 times 0.0766 times 0.4 times 40 times 65 squared all over 32.2. By computing it to the 172.87 pounds. Let's move to the determination of rolling resistance, which is given by the formula R sub R equals the quantity C sub Rs plus 2.15 C sub RV U squared multiplied by W. So as you can see, this formula for the rolling resistance is the formula for the passenger car, since on the problem it is the passenger car that's traveling. The C sub R is also constant for the passenger car, which is 0.012. The C sub RV is given by 0.65 times 10 raised to negative 6 second square all over square foot for the passenger car, and the W is 4,000 pounds. Again, substitute the given to the formula, which gives us the quantity 0.012 plus 0.15 times 0.65 times 10 raised to negative 6 times 65 squared multiplied by the weight, which is 4,000. And it gives us 71.62 pounds. And next, the last resistance that we need to compute is the grade resistance, which is simply given by the formula weight times grade. So weight is 4,000 times. Since the grade is 5%, so we need to convert it. So pi divided by 100, which gives us 0.05, and then 4,000 times 0.05 is equal to 200 pounds, which is the grade resistance. Now the next step is we need to add all of the resistance to get the total resistance. So R is equal to air resistance plus rolling resistance plus the upgrade resistance, which gives us 172.87 pounds plus 71.62 pounds plus 200 pounds is equal to 444.49 pounds. The final step is to determine the horsepower produced by the vehicle to overcome all of those three resistance force. So the formula is P is equal to 1.47 RU all over 550, where the R is the total resistance given by 444.49 pounds, and U is the vehicle speed, which is 65 miles per hour. So just substitute all of those given, which gives us 1.47 times 444.49 times 65 all over 550, which is equals to 77.22 horsepower. Therefore, 77.22 horsepower is needed for the vehicle to overcome all of those resistance forces that acting on the passenger car while it is in motion. That's the end of today's topic. Thank you and have a great day.